Por el camino del desierto, el viento me despeina, suave aroma de colita, nada del área.
Hello and welcome to the concepts video on section on composition of functions. So in the previous sections, we've been learning how to deal with functions such as like f of x, like g of s, and h of t, and it doesn't really matter the variables you use, and etc., right? So there's something common shared by all of these. It's just that we have one function, like for example, f of x. F is the function, and x is the input value, right? In this one, g is the function, s is the input, h is the function, t is the input likewise, right? But now, sometimes it makes sense in real life for the input, such as our x, s, and t in this case, for our input for a function to be another function itself. Okay, that might sound a little bit weird, and it's like, whoa, inception kind of thing, but let me show you an example of like a real life situation in which this would happen. So let's think of one, how about, here's our example. So how are we going to represent the cost to heat, as in with a heater, to heat a house, okay? So you live in a house and you're trying to figure out what's the cost to heat a house, your house, on a given day, okay? On a certain day in the year. Alright, so the first thing is, well, the cost to heat a house depends on the temperature that day, right? Because if it's cold, then you're probably going to be using your heater more, and if it's hot, then you're probably not going to use the heater at all. So we have the cost depends on temperature that day, okay? Alrighty, so is that all? Not quite, because we do have that, well, it depends on what time of the year is it. Like if it is winter, then it's probably going to be cold that day, but if it's summer, then it's probably going to be hot on a certain day. So then we also have that the temperature depends on the time or day, specific day, of the year that we're looking at, okay? So how are we going to represent this whole relationship between three things, cost, temperature, and day? How are we going to represent this using functions? So let's look at the first arrow. So we're saying, well, cost depends on, this is keyword, so depends on temperature. So that means we could represent this arrow here as, with another arrow, C of temperature, so T, let's say. So C of T, that makes sense, because if you're given a certain temperature, you can say, okay, how much does it cost? How much does it cost to heat your house given that temperature? Okay? And then let's look at this other arrow here. Now we have temperature, which I already circled, depends on time or day of the year. So we'll just like take day out of that. So we'll say, well, this relationship, this arrow, can be represented by T, temperature, and then with an input of what day it is, what D, or what day of the year. Okay? So in this case, we have two they look like different functions, and they are. So we have a C of T, which represents the cost depending on temperature. And then this T of D, down here, we have, that is temperature depending on day. Okay? So temperature is a function of day. So what we're going to do now, in order to represent this entire sentence at the top, which I'll circle right now, so in order to represent this whole thing and relate both of these functions together, what we're going to have to do is kind of compose the functions, all right? So see how kind of like the bridge in between these two functions is the T, right? The capital T shows up in both functions here. In this case, this is the function itself. That would give us the output, temperature, right? And then whatever we output here based on the day, we're going to stick it in to be the input in our cost function, okay? So this is what that looks like. All we're going to do is compose our function, so C of T, that looks like our original one here, right? And then T depends on D as well. Okay, so we kind of, like I said, it's kind of an inception thing. Something's inside of another thing. So this is called our composition of functions, okay? This one down here. And the way you say this is C of T of D, okay? That's the way it's said. Or you could just say it's a composition of functions, okay? And another way to write this, let me write that on the next slide. So we've learned one way to write composition of functions, so C of T of D. So that would be a function is a function. Well, a function takes another function as the input. That's basically what composition of functions means. Anyways, another way to write this would be the following. So we could have, you might see this notation, C and then this operator thing it's called. That's some kind of operator thingy. that I don't know the official name. It just looks kind of like a floating open dot to me. And then, so C of T, that's how you pronounce it, and then of D. Okay, so you say it the same way. Both of these are said C of T and then of D. Okay, and once again, this means cost depending on temperature, which depends on the day or the time of the year. Okay, so now let's do an example of using composition of functions. Alright, so here's our problem. It says, suppose C of S gives the number of calories burned doing S sit-ups, so that many sit-ups, and S of T gives the number of sit-ups a person can do in T minutes. And then we're going to interpret what this little phrase says, C of S of 3. Okay, so let's break this down. So we have C of S. Let's identify what our functions are, the ones that we're going to be composing. So C of S gives you a number of calories burned, based on, which is dependent on, so we'll just say based on S number of sit-ups. So if you do like 10 sit-ups, then you just plug it into C and find out how many calories you burn doing 10 sit-ups. Okay, and then we have this other function here, which is S of T, which gives you the number of sit-ups a person can do, can do in T minutes. Okay? Alrighty, so if we were to compose these two, we're just going to take, kind of bridge the gap with that S there. So we're going to take this function, and whatever the output is, whatever our S turns out to be, the number of sit-ups, we're just going to plug that into the input of our C function. Okay, so the way we're going to compose this one is C of S of T. Okay, so that's what the composition of functions looks like when we compose those two functions there. Alright, so now we're going to break down what does this mean? So let's look at what we're given to interpret. So this statement here. So we have something that looks like C of S of 3 now. Okay, so we see that 3 is actually in the T spot, right? So we could say, well, T is equal to 3. In our case, okay? So this is just like the general function, what it's written as, and this is a given statement we're told to interpret. So this is kind of like, well, we can just figure it out by saying, okay, T equals 3 because 3 is in the T spot, all right? And T represents T minutes, right? So this means when T equals 3, we're at 3 minutes. Okay, so that's our starting point. This is basically the independent variable for our composition of functions. So with T equaling 3 minutes, then we could say, well, the inside, it says S of 3. Okay, so that's one key thing that I want to point out. So this is the really important thing about composition of functions. So key idea or key process, you could say, is with composition of functions, what we want to do is work from inside to out. Okay, and we'll be doing this over and over and over again in all the kinds of problems that we do with composition of functions. Okay, so I started on the innermost, right? The innermost parentheses was the 3. Okay, so I figured out what T was. T is equal to 3. Okay, and then we work the next thing, or the next outer thing, I guess you could say. So then that would be looking at the S, right? What does S of 3 mean? So let's look at that. So S of 3, based on our S of T function, that means, okay, so this S of 3 means the number of sit-ups, you, or one, can do in and it isn't T minutes anymore because we know what T is. So for our particular case, our T is 3. So we could say that you can do in 3 minutes. Okay? So now we've broken it down to now we know what S of 3 equals, or what it means or signifies. So S of 3 is the number of sit-ups you can do in 3 minutes. Okay? Now we're not done because we can't forget about this C on the outside. So let me continue this on the next slide. So we have C of S of 3 that we're trying to break down. And now we know, well, this S of 3 is equal to the number of sit-ups you can do in 3 minutes, okay? And so now we're almost to the outermost function, or the outermost place, right? So we did the 3, we analyzed that, we did the S, we analyzed that, so now we're just going to work to the C. And remember, we looked back at our C of S function, and that gave us the number of calories burned doing S amount of sit-ups. Doing S sit-ups. Okay, so if we break this down even more, we could say that C of S of 3 ultimately signifies, or this signifies, the number of calories burned doing the amount doing, you could just say the number, doing the number of sit-ups one can do, or you can do, in 3 minutes. Okay? Minutes. And notice how here we don't have a specific number or anything because we don't really know what our S function is, so we can't tell based on 3 minutes. We can't plug that in anywhere because we don't have a formula yet, right? So anyways, so this is going to be our answer. This shows what C of S of 3 signifies in terms of the functions that we were given.